So in this video, I'm going to work through an example uh, to help you with assignment 5. So in assignment 5, I provided you a data set, and that's on Blackboard. And this data set has 7 variables. And if you downloaded the assignment 5 data file with assignment 5, and if you have Excel, you can open the data file, and this is how the data file looks like. I'm going to minimize this one. And the first question I'm asking is about the race, gender, and English variables, and I'm asking for it to create the frequency and percentages, and also asking it to create some bar plots. And the second question, I'm asking about mean and standard deviation for 3 continuous variables in this data set. And question 3, I'm asking you basically to run an independent sample t-test. So let's work on this one. Okay, so if RStudio is not working on your machine, or if you are having issues with installing some of the packages, then the solution for that one is using RStudio Cloud. And this is a free service, and you can sign up using either an email address or using a Gmail account. So I already signed up for this one, so I'm going to log into my account. And let's go with this one. Alright, so this is going to be the screen when you open RStudio Cloud. And the first thing I'm going to do is I'm going to create a new project. And it's here, you can see that there's like 2 options, but let's just say plus the new project. So it may take a minute or 2 for this to load. So I'm just gonna wait for it. Yeah, you cannot do anything else. So basically what this is doing is this is creating an RStudio session, RStudio app session, as if you are using RStudio on your local machine. So yeah, this is the exact same setup that you will see. And I'm just gonna change the project name to go example. Okay, so as I said before, I don't like how this one looks like. I'm just gonna change how this pane layout looks like. I'm gonna put the console at top right, and also make sure that environment shows at the right bottom, and click apply. And yeah, and I'm gonna make the font a little bigger in case you're having issues. And yes, so right now I have like the top left is where I put my code, the top right is where R is, and bottom left is basically shows when you have done anything, it will show it here. For example, if I wanna do 2 plus 2, it will show in the history. Like 3 plus 3, it will show in the history. So we don't need this one. So I'm going to minimize this one. And so I'm going to save this syntax as example or work example. So, and right now in the right bottom panel, I have environment, I have files, I have plots, packages, and so I'm going to mostly need to use these 3: environment, files, and plots. So the file is basically the files that I have in my working directory. And since this is cloud, you can see that there's now like only 3 files here. And for this example, like in the assignment, I was asking, like, checking like frequencies and plots. So you don't need to start from the beginning. And what I'm going to do is I'm going to bring some of the codes that I shared with you before. And to do that, I'm going to upload those syntaxes to the cloud. And to upload those, I'm going to click this upload button on the right bottom panel under Files tab. and I'm gonna browse, and I think I shared this one before. So, yeah, let's see. So from this lab session 8 that I shared before, I'm gonna get the first R syntax, and R files ends with .r. I'm gonna open that one and I put that one here. Okay. So yeah, when I open that one, what it says, I'm missing some packages, and I'm just gonna click install those packages, and this might take a few minutes to install, and you will see this at the top right. You will see the stop sign, and whenever the stop sign is there, it means that R is working to do what you asked it to do. So we need to wait until that part is done. But in the meantime, what I'm going to do is I also need the data file. For example, for this example, I was using Linda. So what I'm going to do is I will, and then first I put that folder, data file, in a folder called data. So the first thing I'm going to do is I'm going to create a folder called data. Okay, yeah, perfect. So it's asking me to name the data file, name the new folder, so I'm going to name it data. Let's doing installation in the background. So, okay. Okay, I'm just waiting for art to finish the upload, otherwise it's creating for the very slow. So it's still doing some installation in the background. Okay. So whenever you see this less than sign, then means that R is done. And since I might create a folder called data, and so that right now there is nothing in this folder. So I need to find the one.lambda.xlx in my folder so that I can upload that here. So let's upload again. And again, in the lab session 8, I have a folder called data, and the first file is the data file that I need. Okay. So now I have the data file over there, and I have my sample syntax that I provided before is here. And so what I'm going to do now is I'm going to get the parts that I need from the syntax. First of all, I always need to load the packages, and I also need to read in the data set. So I'm just going to paste that here. So this is a brand new syntax that I'm creating, because in the syntax, in the assignment, I was asking calculate the frequencies and percentages for the descriptive variables. Okay, so I'm still looking at the syntax, and the next thing I have is, so like frequencies, I can use this syntax. For proportions, I can use this one, but here I can use the EC function to get the frequencies and proportions for both. So I'm going to copy that one, Okay. And the next part was, it was asking me to create some bar plots. In this example, I also created some bar plots. So what I'm going to do is I'm just going to copy one of them, like the top one, and I will put that one here. Okay. So right now I have, so I'm going to open the assignment. So in the assignment, I have frequencies and percentages. So this function here helps me to create both frequency and proportions, or percentages. Percentage and proportions mean the same thing in this context. And I have a syntax to run the bar plot. So that's this one here. So let's work through that one. Okay. So the first thing is, okay, let's load the packages. And to do that, you can highlight all of them and then click run, and then that will run the packages. Okay. So I don't need the files tab right now. I'm just going to look at the environment. So my environment is empty now. So let's read in the data file, and then that's what's going to happen. So when I read the data file, I can see that now I have an object called my data, which has 120 observations and 3 variables. And perfect. I can click the text my data, and then I can see what's in it. So it's like the gender, ethnic, and job in this one. So if I want to look at the frequency and proportions by gender, then this is the function that I need to use, like DEC. This is part of the DEC tools, and some of you are having issues installing this package. So my data is the data file name that I want to use, because I read in the Linda, and then I named that as my data. And $ is used to call a variable from that data set. And if you look at the data file, there's a column called gender, ethnic, and job. So I will just run that one, and to run it again, you can either bring your cursor anywhere in the line, and then click run, and it will run it. So I don't need this plot, so I'm going to save it as plotted. You don't need to know all of this syntax. The only thing you need from here is DC function gives you the descriptors. So I'm going to clear this one by clicking this brush. I should want to remove the plots. Yes, I want to remove them. I'm going to clear this one here because I want to rerun the code. Okay, so I'm going to rerun it now, and then let's see what happens. So when I run this function, my data is already in, and it's called my data, and I'm calling a column called gender, and I want to look at both frequencies and percentages. So when I run this one, it will just give me that, like frequency. There are like 62 women in this data set and 58 men, and it also gives me the percentages. Okay, so so this is how you do the percentages and frequencies. So in the assignment that I was asking, like, do the same thing for race, gender, and English. So what you need to do for that? So you need to change this one to race to look at the race. And if you want to look at the English, then you need to change that to English. But make sure that your variable, this name here, matches the variable names in your data file. Okay. And yes, so that's how you get the percentages and the frequencies. The next step is create a bar plot for race, and I'm saying fill using race variable. Okay, so what is this one? What is this one? And I have race called ethnic, but since we're focusing on gender, let's just focus on gender. And yeah, to create the bar plot, this is basically what you need. You need to use a function called ggplot. This is part of the ggplot2, and gg is a shortcut for grammar of graphics. And yeah, the first argument is the data file, This is a shortcut for aesthetics. And axis fixed, it has to be always x. That means that's the x-axis. And I want to plot gender on the x-axis. And I want to fill gender with gender. But before that, I'm just going to remove this one and run the plot. And let's see what happens. Okay. So this is now what I get as a plot. It's a bar plot. It just tells me the frequencies of men and women. And we know from the frequency there's like 58 men and 62 women. And yeah, this is like a little short of 60, a little 60. So 58 and 62. And I wanted to use, I wanted to color these bars. But to color it, you just need to use an argument called fill. And I'm asking to color it by gender. And if so this is the syntax you need to use to do that. And everything else stays the same. And if I run this one, look what happens. So now the bars are colored by gender. Okay. Yes. So, and then some other questions I have is like create a bar plot for race, fill using race variable. So if you have a race variable in the set, you need to just change this to race. And this is the x-axis. That tells us like what the bars are for. And if you want to fill it by race, you just need to change this to race. And that will color each bar based on specific gender. Okay. And so let's say I don't have race, I have ethnic in this one, but yeah, I can color the bar by ethnicity, or I can create a bar plot by ethnic and fill each ethnicity by gender. But again, the crucial point here, you've got to make sure that the variable names matches the variable names in your data file. And again, to open the data file you just read in, you just need to click this one. Then you can see there are 3 variables, and these are the variable names: gender, ethnic, and job. In your data set, it might be called race. So if it's called race, then you need to change this to race. Okay. So I'm gonna run that one. So yeah, this is what happens now. So since I put ethnic on the x-axis shows like Asians, Black, Hispanic, other, and white. And since I asked to fill it by gender, like for each ethnicity, now I can see like whether there are more men or more women in that ethnicity. Okay. So yes, this is the yeah, this is how you can do the frequencies and percentages and also the bar plot. Okay. And perfect. So the next thing I was asking is, I was asking to run an independent sample t-test. Okay, so how do we do that? Okay, so this descriptive statistics, that the syntax that I gave you and I showed you earlier, like where to get that from, that doesn't include independent sample t-test. So I need to use another syntax to do that. So where is that one? Okay. Yeah, lab impression stuff. And so the example, yeah, it's called independent sample t-test happy face. And I shared these folders on Blackboard. So I'm going to open this one and I'm going to upload that. So independent sample t-test. Okay. So it looks like for this one I'm using for.happy.xlx. So I need to find that data file and then put it in my data folder. Okay. I'm gonna go there, upload, browse, and data, and for happy. So I'm going to upload that one. Okay. So I'm going to copy all of this. Put here. Okay. So it looks like I need this library that wasn't here before. And DC2 is already here. I don't need, and I have read Excel, yeah. So I don't need any of these packages. So this part is for independent sample t-test. Okay. So again, this one is a different data set, and I already have my data in the environment. If I read this one, it's gonna overwrite that one. So I don't want that. So what I'm gonna do is I'm gonna call this one my data 2. But I need to update all of these after that, because all of this comes from this data file. So let's read in this one, and click run. So now I have a second data set that's called my data 2, because it's a new data set that I'm reading. And I'll open that one, and it looks like I have two variables here. One of them is called tips, and the other one is called happy. And the details about like what this data set and what it does about each of those was explained in the PowerPoint slides. And so I'm going to copy these two. I'm going to paste that one here. Yeah. So this is how you run a t-test. So you basically put your outcome on the left-hand side, and this is tilde, and basically it means that tips by happy. And what you're doing here is happy has two categories, and I can actually do the descriptor for that one and then see how it looks like. So my data set called data 2, and I'm going to plot it. So let's run what it looks like. So it looks like I have 23 participants who received a check with no happy face drawing on it, and 22 of them received happy face. And our goal in this analysis is we want to compare whether drawing a happy face on the checks will change the amount of tips the server receives, or whether there is a significant difference if you draw the face or not. So that's basically what we are examining. And the rest is going to stay the same. And so this needs to be my data 2 because I'm using this data set instead of that data set. Those are two different data sets. Okay. And to run this one, I will just run it. So yeah, that's it. So there's a two sample t-test, and I'm looking tips by happy, and the t-statistics is 0.80, and the degree of freedom is 43, and the p-value is 0.42. So since the p-value is greater than 0.05, we fail to reject the null hypothesis. So basically, what we are saying is there's no difference, statistically significant difference between the happy face and no happy face group in terms of the amount of tips that they receive. Okay, and so okay, let's see the assignment. Okay, we looked at the first one, or we looked at the third one, but we haven't looked at the second one. Okay, let's do that one too. And the difference between the first one and the first question and the second question is, first question is asking includes only categorical variables. The second question includes the quantitative variables. Okay, so in my data, let's see, the first data file, I don't have any quantitative variables, so I cannot use the first data set to get the means and the standard deviation. So I have to use the second data set, and I can only use the get the mean and standard deviations for tips because happy isn't a quantitative variable. Okay, so let's do that. Basically, to do that, what you need to do is nothing exactly like different from the how we calculate the frequency of percentages. You just need to use the DEC function, and you just need to change happy variable to tips. And if I run that one, you will get the means and the standard deviations. Okay, so I'm going to minimize this. I'm going to clear up the space so that we have a better viewing. And when I run that one, voila. So this is the kind of like the descriptors for tips from the second data set, and the mean is 30.77 and the standard deviation is 9.3. So this is the only information that you need from this one. Okay, so yeah, and that's all that's all you need to complete the assignment. So you just need to change the data file and then make sure that you use the right data file and make sure that you use the right variable in these spaces. Okay, and this is extra, but I can also do this here. And then, again, this is extra. So if you want to know whether for this independent sample t-test, what's the mean for both groups, this is basically what you need to do. So tips by happy. And if I run that one, let's see what's going to happen. So if I run that one, I got the mean for happy face and the mean for no happy face, and I have the standard deviation. So, okay, I think that's all. Again, this is extra. I was asking about this in the assignment, but this is all the syntax you need to be able to complete the weekly assignment 5. Okay, and so again, make sure that you're uploading the right file. And again, you can use this RStudio Cloud. It's free. You can create an account. And at the beginning of this video, I showed how to create a workspace and how to upload the files. Okay. So that's it. Okay. I'm gonna end the video.